Welcome to this Architecture Today webinar with Business Sprinkler Alliance, Designing for Fire, as we explore the key strategies to creating safer and more sustainable outcomes for everyone and the impact of fire in the context of resilience and sustainability. We're delighted to have 4 expert panellists who will be taking part in the panel discussion later, chaired by Jane Duncan, past President RIBA and Director of Jane Duncan Architects. The format for today's webinar has each of our expert panellists setting the scene in a brief presentation from their own perspective, that of insurer, fire chief, fire engineer and architect. There's also the opportunity for Q&A along the way, so if you'd like to put your question forward, please click on Q&A. Coming up, Iain Cox, former Fire Chief and former Chair of the Fire Risk Assessment Competency Council, current Chair of the Business Sprinkler Alliance, BSA, Vice Chair of the National Fire Sprinkler Network, NSFN, and Board Member of BAFE. Then we'll hear from Mark O'Connor, Director, Structures and Head of Specialist, Property and Buildings, WSP. Followed by Paul Bussey, Technical Design, CDM Fire Access Lead, ALLFORD HALL MONAGHAN MORRIS. To get started, let's begin with Tom Roche, Senior Consultant, Codes and Standards, FM Global, with the insurer's view.
Thank you. So when I was asked to sort of talk on this subject of designing for fire, I realised that I scribbled down the same things over time as I listened to the issues around fire that have been coming up in the press and perhaps over my career. And that's why this is just about 5 things. I work for an industrial commercial property insurer, have done for nearly 30 years, worked extensively in the built environment from construction through to sort of operational building issues. So I just want to talk about 5 things, and that's what this next 10 minutes will hopefully cover. So those 5 things. Firstly, a word I keep writing down is who. And I'll explain a little bit more as we go through this. And then clarity of outcome. What do we expect to happen from a building in the event of a fire? I'm a child of the 80s, so I remember the era of glasnost. So there's a phrase that was used a lot back then, and it's stuck with me through my life, which is trust but verify, and that's very important right now. Then there's managing change. As an engineer, I realised that buildings change over time, and therefore there's a need for management. And working in the insurance industry, I'm used to assessment, ongoing assessment of issues in the built environment and needing to do that. So I'm going to take you through those 5 things and why I think they're important to designing buildings for fire. So as a bit of a stage setter, I just want to talk a little bit about buildings. Buildings are incredibly complicated. I know we often talk about them as in construction or in operation, but I think we forget there are a myriad of different outcomes that we are trying to achieve with a building, from its structure to its envelope, to the services that we put inside it. And then we expect different outcomes from that in terms of how we'll feel when we're in that building, how it will respond when it's, subject to weather, through to if the worst happens and there is an incident, perhaps a fire, how will it behave? And as an insurer, it's one of those things where fire is top of my mind, but I think it should be the top of more people's minds. I know recent events have brought it there, but it continues to be a significant cause of damage to our built environment. This pie chart shows that about 65% of the losses that the insurance industry pay are, relative to fire, and that figure doesn't really change year on year. Fire hasn't gone away as an issue; it remains there. So those 5 things. Who? We've probably talked a lot more about who recently, but who for me covers a lot of things, from who's accountable for some of the issues around fire and what do we do in the event of fire, through to who's doing certain actions, and are they the right people? Do they have the right skills? You'll see a flavour of this as we think about the Building Safety Bill and some of the implications of that for accountable, responsible people, similarly with the Fire Safety Order. But for me, a lot of things start with, well, who's making some of these decisions? Are they the right people? when it comes to designing issues around fire, have they got the right skills? Have they been given the right outcomes to achieve? And that's where we step into the second part, which is, well, what is a successful outcome in the event of a fire? Forgive me, but this is a large school fire that's happened in the UK. And to some, they can tell me that this is a successful outcome. No one was injured. The fire didn't spread to any other property. This is successful. And I look at that and it doesn't really pass the smell test for me, but we've got to be clear, what do we expect from a building in the event of a fire? If you want that to be a success, that everybody gets out safely, the building is disposable, that could be success. If you want to be able to use the building tomorrow, then maybe it's not. The thing that we need to be clear about is people often refer to regulations in this respect. And it's at this point I've got to really stress, in terms of outcome, regulations set the floor. They're the minimum. Despite what people may think, you can't limbo under them. This is the minimum. But that does not mean you're going to get all the outcomes you want just by following the regulations. And often when I talk about clarity of outcome, what I'm really trying to say is be clear what you want from a building. Don't assume just because you're following the regulations, you're going to get the right outcome. It's something you need to share with the designer and others doing that work for you. And I'm somebody who travels into London a lot, and I always see this sign, and it always reminds me of this. There's a gap. There's a gap between what people think is the outcome delivered by regulations and perhaps what they want. So if you want your building to be resilient to fire, you want the business continuity, you want to be able to use the building tomorrow, you've probably got to ask for different outcomes than regulations deliver. So be clear on the outcome you want from a building in terms of a fire. Then there are many solutions. I'm an engineer working in the insurance industry. I help clients with all types of solutions for fire and natural hazard type issues, from materials to put on buildings that will limit fire spread to that won't burn, through to what are some of the strategies you need to employ to keep your building safe, through to a simple device like a sprinkler system, which is a fantastic solution in terms of minimizing the impact of fire. As I said, I'm a child of the 80s. And there's one thing that keeps coming back. Whatever the solution you choose, you've got to be clear. Does it work? Will it do what I want? Will it give me the outcome that I'm seeking? And that's wrapped up into these words, trust but verify. What do I really mean? Well, for any of you who've watched parts of the Grenfell inquiry, or have been subject to some of these discussions about remediation of buildings, one of the things that may have struck you is how everybody's trusted that somebody will do the right thing. It's somebody else's responsibility. Somebody else will take care of that. What I've learned through my career is it's okay to trust people, but you do need to verify that the solution is the right one, the solution will deliver the outcome you want, but at the same time, that solution that you're being offered is actually suitable for your building. And so therefore, I'm not suggesting everybody needs to go and check all the calculations that are ever done by somebody else, but there are some intelligent questions that you should be asking when you're designing a building or being offered solutions that can assure yourself that it's okay. I still remember as a young engineer, one of the most terrifying questions I was ever asked. And it was by an eminent metallurgist after a repair to a large machine, who turned to me as an engineer and just said, "What have you done to satisfy yourself that this is okay?" And in that question was a lot about my technical ability to assess the solution, to check that something had been done correctly, and not just assume that somebody else had done it for me. My responsibility was to ensure it being done. So he was verifying, not just trusting me. I think that's something that we need to sort of keep hold of. And it's not rude. I know some people say, well, it won't build trust if I keep asking questions. No, that's just good professional sense. The next part of those five, or the next point, is about change. So many of you will have traveled into London. This is an artwork for London about 300 years ago. Some of those buildings that are on this side of the screen are still there today. But this is probably what we're used to. And my point is, the built environment continues to change. It does not stand still. The buildings that we develop today have a particular purpose. We'll transfer them to new purposes going forward. What starts off as perhaps a block of offices might transfer into being residential accommodation. It may transfer into restaurants and a hotel. All these things can come to pass because a building is not just for a year or two. The life expectancy of many buildings is 40, 50, 60, 70 years. And during that time, we'll use it in different ways. The key thing is what we designed in the first place for fire may not be appropriate for some of those changes. So therefore, we need to manage those changes. You'd have heard the term the golden thread. Information is vitally important when we manage change, but you've got to stay on top of the changes. What do they mean for the outcome I want for the building? Has the outcome changed? And that really lends itself to my next point, which is about ongoing assessment. This simple diagram is very, very familiar to a lot of people in the risk management profession. I think it's very familiar to anybody who's monitoring a process. We often go through processes to identify whether there are issues, make an assessment of them. We then set in place plans, we execute those plans, monitor those plans to ensure we're getting the outcomes we want. But we always come back to if there's a change or if something it needs to be sort of like managed in the process, we go through that process of assessment. And that ongoing assessment is something that keeps us in the right place. It means we're no longer resting on our laurels. We're checking to make sure we're going to get what we expected. And in the world of fire, when we think about that and the lifespan of a building, ongoing assessment to check nothing's really changed, the hazard hasn't increased, the risks haven't increased, is very, very important. So I fall back onto my just 5 things, that element of who, and when I say that, it ranges from responsibility to competence. That clarity on outcome, be clear, do you want to meet the minimums or is it something beyond that? That Glasnost era phrase, trust but verify. I know it doesn't sound like a great way to form partnerships, but I think everybody understands there's a need for that verification. That's that surety that I've done my job, I'm getting what I want. And at the same time, it's a legitimate challenge. And in the engineering world, that level of third-party scrutiny is the norm. And remember, things changed. If you remember the Billy Connolly business plan, I won't say it all, but stay awake. It's all going to change tomorrow. And the built environment is very much like that. And that's why we need ongoing assessment to ensure we're in the right place. So whatever solutions we choose, we know that we're building from a solid base. And that's really what we need to achieve when we're talking about, designing for fire. And I think it's about just those 5 things. Thank you very much for your time.
Thank you, Tom. The panel discussion and Q&A follows after our presentations, but next we look at designing for fire through the lens of a former fire chief and former chair of the Fire Risk Assessment Competency Council, current chair of the Business Sprinkler Alliance, BSA, vice chair of the National Fire Sprinkler Network, NFSN, and board member of BAFE, Iain Cox.
Thank you very much, and thank you for the opportunity. You can see the title of the talk I'd like to give today is Compliance, Is This Really Success? Because the pictures you see on the screen in front of you were all compliant buildings. What compliance means can vary from code to code, as we'll see during the talk. But people generally believe buildings are compliant, but that doesn't mean they're fireproof, because compliance means life safety. It means everybody can get out before the building collapses. And I'm not really sure that we should be counting that as a success. Before I carry on, I'm speaking today in my role as chair of the Business Sprinkler Alliance. We have a website if you want further information, but as you can see in front of you, we're established in 2010, and we have the following members: BAFSA, the British Automatic Fire Sprinkler Association, the National Fire Chiefs Council, the European Fire Sprinkler Network, FM Global, the not-for-profit insurers, the Fire Protection Association, and the National Fire Sprinkler Network. We are an alliance. We really are pushing the fact that we believe people underestimate the benefits and overestimate the complexities and costs of sprinklers, especially in business. Going back to the regulations, England, Wales, Scotland, Northern Ireland, the UK, it's rather complicated, as we're probably seeing with all the COVID restrictions varying from administration to administration. So too do the building regulations vary. England and Wales are fairly close, but of course the Welsh measure passed recently means they're sprinkling all residential properties on an ongoing basis. The compartment sizes and building use change slightly, but the fundamental thing is that the life safety focus underlines all of these. We will see that the differences occur, but the difference between the regulations within the UK and outside the UK, of course, are even more pronounced, and we believe we have some lessons to be learned from other countries. Approved document B is in both England and Wales, but they are different, as I mentioned. The guidance technical booklet E for Northern Ireland, and the technical regulations for Scotland. So those are the documents that you would refer to for fire safety in buildings in those administrations. So the regulations are there, but are they understood? Well, back in 2016, the BSA did a survey, a YouGov survey, 442 small and medium-sized enterprises, so a fairly big survey. And roughly 70%, 69%, thought that because the building they were in had received approval, had been approved by building regulations or building standards, they felt that their premises were adequately protected from fire. Now we know that's not the case, because as I said, it's about life safety. So evacuation before collapse is deemed to be a success, although it shouldn't be in my view. Therefore, your building is not protected from fire. Your business is not protected from fire simply by the fact that it's passed building control. So there's a clear misunderstanding from business in general. So the Building Safety Bill, which is the draft is out, as we all know at the moment. But we've got a point here that I'd like to pick up that not everybody picks up on immediately. It says that the regulator, which was yet to be appointed, will oversee the safety and performance of all buildings, not just the higher risk ones that they'll concentrate on. And the other thing they say is that it's for the safety of people having resort to that building, but also to the standard of the building as well. So the standard of buildings in general is under the remit of the regulator, although clearly they will have a focus on the higher risk buildings. There are various, it's a draft bill out for consultation, so it may well change, but there are various aspects which I'd like to pick out. Section 39 focuses on industry competence, and there's a committee for industry competence under Section 10. So there's a whole framework to ensure that competence in the building industry is increased. Enforcement under Section 42 is also mentioned, and particularly important 2 points. One is that they will have the power, the regulator will have the power to give stop and compliance notices. Stop notices, in my view, are very powerful. Nothing focuses a developer's mind more or a builder's mind more than the fact that some official can come in and say, stop all work. If that were to happen, that has an immediate and profound effect. Therefore, they will try their best to avoid that happening. So this, in my view, is a very good incentive. Also, the regulator will be able to go back 10 years, considering more than now. The Section 44, the regulation of building control, will be changed. The building control will work differently in the future. How is a very good question. The HSE will have the lead, but they will have to involve local building control, or local authorities, or whoever's in charge of the building approval process, and the fire and rescue services for the area. And again, going back to an old service adage of one name, one neck, we will both have an accountable person. Section 61 will define that, and Section 67 says that there should be a building safety manager. Remember, this is for the higher risk buildings. So there are at least 2 people there who will be held accountable, and you only have to see how harrowing it is to be dragged up in front of an inquiry. Imagine what it's like going through a court case where you haven't done the right thing for your building safety. In the future, you will be held accountable, and I think that's another powerful tool that's contained in the bill. So that's the Building Safety Bill. the point I would like to draw attention to on the bottom is we've all heard of the triangle of fire. I have a small triangle of non-fire. It consists of those three things: the appropriate regulation, the appropriate enforcement, and the appropriate competence. You need competence both in regulation, enforcement, and indeed in construction, in building industry itself. But I think if you have those three things, you are far less likely to have a severe fire, and it's less likely to injure or kill people. There is another survey that's much more recent, of course. It isn't the BSA. This was the Chartered Institute of Builders, who in September the 21st released the results of a survey. 156 built environment professionals were consulted. They said that the biggest obstacle to implementing the golden thread, which is this continuous chain of information you need to make sure you're making the right decisions about fire safety in buildings, that the biggest obstacle was the industry culture itself. This is the industry saying that its own culture is the biggest barrier to making sure that one of the key factors we'll need to make buildings safe in the future, this golden thread, may not happen because the culture itself won't mitigates against it. Some of the direction of travel in the UK, in England in particular, is particularly promising. We're suggesting, it's not been passed yet, but all the indications are that we may move to 11-metre height in order to have sprinklers or other fire safety measures required in higher-rise buildings. That would move us from where we are now to one of the best in Europe. You can see that other countries, I mean, France is 200 metres. We're not showing Italy because I can't show infinity on the picture. They have no limit, it will go straight off the top. But we were fairly on the good end of the scale there. We'll be even better. So in some ways we are the best in Europe, but also, I'm afraid, in some ways we're the worst. When you go to warehouses, you can see there from the diagram that England and Wales at 20,000 square metres, Scotland slightly less at 14,000 square metres before you're requiring sprinklers. Both of those figures are way above the average for the European. As you can see down there, Norway at 800 square metres. Incidentally, India has just changed its own guidance on warehouse compartment sizes, and it's even less than Norway before you have to have a sprinkler in warehouses in India. I believe it's 700 square metres or 750. So we believe that there is much being done that is right, but some areas need further information, further effort. One of the key points we would make here, or I would make here, is that when you fit sprinklers, you must also have a sound building. A lot of people think that the sprinkler advocates, such as myself, just want sprinklers everywhere and we don't care what else happens. This is not the case. Actually, what we've got is you need to have sound buildings, which is where I think the Building Safety Bill, or Act as it will become, will pave the way. And you can see there from the purpose group lifted from approved document B that indeed the storage size is 20,000 square metres in the UK in England and Wales, all greater than 18 metres. The point I would like to make, though, is I believe those purpose groups are out of date. If you look at modern buildings in the industrial sense, they are multifunctional. Whether it's an Ocado warehouse or an Amazon fulfillment centre, you've got elements of both warehouses and factories and industrial units in general. It's very rare, I think, now that you're a pure warehouse or a pure factory. I would advocate that we should actually be including storage 7A with 6, industrial single story, or indeed multi-story. The other problem is with mezzanine floors and such like. Indeed, the recent Sony judgment, I believe, the judge actually said that you should be including mezzanine floors in the size area. A common sense approach that we were taking in fire safety for many years, but now it's almost enshrined in law because of that judgment. So moving on, we also have some anomalies. There are several of them, but just to highlight the sort of thing. If you have a 30-metre block of flats, you have to sprinkler it. If you have a 30-metre hotel or student accommodation, you don't. They could be identical. Actually, I should have used the same picture. I would have made the point even better. But they could be identical. But the one would require sprinklering and the other two wouldn't. And in my view, if you live in a flat, you tend to know it better than if you're staying in a hotel that you haven't been in before, or indeed if you're in student accommodation. I'm not sure that student accommodation is inherently more safe than flats. We would say they should all be treated the same. Another misconception, really, that we'd like to shine some light on is fire is under control. Here are some figures from the Fire and Rescue Services. This is where damage was recorded, so it could be 1 metre to thousands of metres of fire damage. If rounding the figures up, you're talking about 1,000 industrial fires a year, 120 odd recycling centre fires, and 250 odd warehouse and bulk storage fires, 400 odd office and call centres. So industrial commercial properties do burn down, or affected by fire, and in many cases burn down completely. This is to fight against this understanding that fire doesn't happen, or indeed a subset of that belief is it won't happen to us. It does happen, and it may well happen to you. It is not as common as it used to be, and that's a good thing, but there is still quite a proportion of fires happening in industrial commercial buildings in this country. And that's why we're advocating sprinklers as a very useful control measure on those fires. Again, from 5 years of Fire and Rescue Service data, we can show that they operate reliably 94% of the time. They are effective 99% of the time. 95% of the time they involve fire sprinklers or less, and indeed 65% one sprinkler only. This is a very, very effective tool. It's more effective than Fire and Rescue Service. I speak as an ex-firefighter, but it's more effective than a Fire and Rescue Service because it's there and it's ready to go. Yes, occasionally you get failures. When you dig into it, it's usually human error somewhere along the chain. Wasn't properly specified, wasn't properly installed, or that's very rare because third-party certification, etc. But basically, people don't realise how good sprinklers are. My job with the BSA is to, make that point again and again. And just to round up, to show why fires are more prevalent than people think, here's a case study. The Daventry Industrial Park fire, Gardner supplies, 38,000 square metres, almost twice the size it should have been sprinklered at 20,000 square metres. There's a whole story behind why it wasn't. I won't go into here, but it is indicative that this often happens. We build bigger than we should do, and without sprinklers. In March 2018, it was a severe fire. It destroyed it. Lost 20 million in stock, 30 million in construction. So that £50 million loss was one thing, but other distributors and sellers lost profit because they didn't have the product to sell. And indeed, even worse, the whole company, Gardner, went into administration in October 2018. So despite the fact it was a BREEAM good, 3-star BREEAM property, so environmentally it was very good, but any environmental savings literally went up in smoke. It was wrecked. The rebuild cost, I don't think it was rebuilt, so you lost the economy and the jobs to the local area, but somewhere they'll have to stock this material again. And if you rebuild that property, then you've lost any environmental savings you made it in the first place completely. So I hope that's just one case example. There are many, many more on our website. I hope in 10 minutes or so I've just wrapped up why, as an ex-fire officer, as a chair of the Business Sprinkler Alliance, I think we're underestimating fire. I think we're not looking at the complexity of buildings that we're putting up, especially in industrial commercial buildings, and that we need to future-proof the buildings for the future for the country's benefit. If you lose a building, even if nobody dies, I don't think you should call that a success.
Thank you, Ian. Just to remind you, Jane Duncan, past President RIBA and Director, Jane Duncan Architects, will be chairing the panel discussion immediately after our opening presentations. And if you'd like to ask a question, please click on Q&A. Next, we turn to the fire engineer's view from Mark O'Connor, Director, Structures and Head of Specialists, Property and Buildings, WSP.
I'm here to give the fire engineering consultant's point of view in terms of designing buildings for fire. And what we like to do at WSP is we like to really concentrate on what we call holistic engineering. And really what this really says is that for successful design of buildings, you really need an integration of all the major disciplinary inputs into the design process. And obviously the earlier that can start, the better the outcome for the actual project. And obviously fire engineering is a very important part of that process because it has a major impact on the functionality of the building. So that, along with all of the other disciplines, the earlier we can get people together to provide the inputs, the better the design of the building. So in terms of fire, and the way I like to describe designing for fire is to really just talk about how fires develop. I'll start off by talking about how fires develop. And generally fires start with something that ignites something in the building, and it will start quite small. But if that fire is left unchecked, then more and more combustibles in the building can start to contribute to that fire. And in terms of the atmosphere temperature in a compartment, how it varies with time, then that will start to grow. You reach a phase where the atmosphere temperature, particularly at the top of the compartment, gets to a temperature where it reaches a phase where the radiant heat flux generated will then start to involve more and more consumables in the compartment. And you'll reach a sort of almost like a runaway phase, which is the term flashover, which is denoted by a very, very rapid rise in temperature as the fire takes hold. Eventually, the fire in the compartment will come into equilibrium with the ventilation, the thermal inertia in the compartment, and you'll get what's called the fully developed phase of the fire, where all the contents now are burning, but it's controlled by the oxygen that comes into the compartment. And typically, the atmosphere temperature would peak around about 1100 to 1200 degrees C, depending on what is actually in that compartment. But eventually, all the consumables in the compartment will actually burn, and then the fire will start to decay in terms of temperature, and eventually go out if it was left unchecked. So I just like to start with that, just to know that let people know there's really a time element in terms of how fire protection systems that actually used to mitigate the effects of a large fire can actually act in a building. So if we use that fire development as a timeline, obviously, in terms of an overall fire strategy, then it's best to detect the fire when it's small in size and obviously lower in temperature. And obviously, one way of doing that is to put in a suppression system, which will actually then cool down the fire and actually control its development, or even put it out when it's actually quite small. And obviously, from a fire strategy point of view, this is quite an effective measure. And then obviously the thing that really sort of harms people in terms of the impact of fire on a building, on the occupants of a building, is smoke and toxic gases. So obviously we need some kind of smoke control system to ensure that it's controlled so that people can actually safely escape the building, and obviously protected escape routes and having safe escape routes out of the building are a very important part of any fire strategy. One other important part is compartmentation, and the effect of compartmentation is manifold, but it can be used to protect escape routes, to make sure that the smoke is kept in the compartment of fire origin. But more importantly, it tries to keep the fire in the compartment of origin and not spread to other parts of the building. And then lastly, in terms of making sure a building is stable during a fire, structural fire protection can play an important part in any overall fire strategy, but really it only becomes important when we have a severe post-flashover fire in the first place. And really the point I'm trying to make in terms of the timeline is that you're probably better off trying to spend more money at the front end of the process, try and stop the fire when it's small, rather than the back end of the process when really you've had a systemic failure of the overall fire strategy to get a post-flashover fire in the first place. So in terms of the regulatory environment, most people are familiar with approved document B, and obviously that deals with the many different aspects of any fire engineering strategy in terms of means of escape, internal fire spread on linings and structure, external fire spread to make sure that the fire cannot spread between buildings or up the building in terms of facades. And then lastly, access and facilities for the fire service to enable they've got an effective and safe route to actually tackle any fire that may occur like that. And obviously the rules and regulations that are in the approved document are mainly prescriptive. And what we mean by that is they are rules which say you shall do this and you shall do that. And if you follow these rules, then you're deemed to be able to satisfy the functional requirements of the building regulations, and particularly the Part B related to fire safety. But there are alternatives, because it is recognised that while it is quite difficult to write prescriptive rules which are applicable to every single building, and there'll always be deviations from that, which, you know, to enable the functionality of the building to be achieved. And obviously, what we have to do then is, as a fire engineer, we have to then develop alternative fire safety engineering approaches. And as it says in the approved document, this sometimes may be the only practical way to achieve a satisfactory fire safety, particularly in large and complex buildings. But the main difference between the prescriptive rules on the alternative fire engineering approaches is that the alternative fire engineering approaches are concentrating on the actual performance of the building, rather than just doing something and assuming that a certain performance will be achieved. So to me, in a simplistic way, this is the easiest way of trying to explain what the whole fire engineering approach is about. So those are really the only points I want to make today. In summary, a fire strategy should really be tailored to individual buildings. No two buildings are the same. And obviously the best fire strategy for that particular building needs to be developed with the rest of the design team to ensure that it's effectively incorporated with any building design. And obviously performance-based design enables us to achieve this. It tends to end up with more economical design compared to prescriptive approaches. Not always. It depends on what the design outcome of the building that's desired by the particular client for that building. It is suitable for most buildings, not just complex buildings, although it is obviously mainly used for complex buildings in the UK. It gives us a much better understanding of the actual behaviour of the building during a potential fire, rather than the application of a series of prescriptive rules. And also it can help us identify the more critical aspects of the overall fire strategy that we need to concentrate on to determine a good outcome for that particular building. And then the last point I'd like to make is that fire engineering as a discipline is not a homogeneous discipline. It requires the inputs of many, many people with specialist understanding of the different aspects of a fire strategy. For example, psychology and human factors for means of escape. You know, the chemical engineering for understanding how materials may participate in a fire or how they may react in a fire. As well as overall functionality of the building, and also firefighter access in terms of that knowledge on how firefighters actually operationally fight fires and making provision in the building to enable them to be able to do that. And really, that's the final point I would like to end up on. Just a few thoughts, really, obviously in a short period of time, on what is a vast subject area. Thank you very much.
Many thanks, Mark. Panel discussion and Q&A follows our final presentation through the architect's lens with Paul Bussey, Technical Design, CDM Fire Access Lead, ALLFORD Hall Monaghan Morris.
Hello everybody, Paul Bussey here from the RIBA Expert Panel, talking about the construction industry and regulations pre and post Grenfell, but also, as reported to the government and the all-party parliamentary group, a complex creeping collective short-sightedness or myopia. Today, I'm going to try and explain, I've been working in this field of architecture for some 45 years, and the last 20 or so specialising in fire design and CDM, and I've been trying to make fire engineering solutions. And now I'm questioning that, to be frank. If I look at any tower block or any housing block, I am now seeing disabled people, I'm seeing elderly, I'm seeing young, I'm seeing other vulnerable people. And actually, there's no such thing as general needs housing these days. Because of our social integration, we're all in the same buildings. So we must deal with the most vulnerable first. Now, if we look at our functional requirements in the regulations, 2010, there are 5 of them, and it's on page 29. And they are incredibly aspirational, but very vague, ambiguous, and non-prescriptive. So even though the Grenfell inquiry has suggested that we failed the external fire spread, B41, we also failed in all other respects, and I'll try and demonstrate that to you. So the approved documents, which everyone believe actually meet the building regulations, it's quite interesting to find that they're not mandatory. And even though it says, or it said in the time of Grenfell that this is pre-2017, that the fire safety requirements of the building regulations should be satisfied by following the relevant guidance in this approved document, it's very clear they don't. So there's all sorts of other regulations or guidance or legislation or quasi-legislation which seems to back this up. Now, this is an incredibly difficult situation as a designer, and if you have an approved document with all this criteria in it, B1 to B5, which are actually in a very non-intuitive design direction, if you like, 1 to 5, on the right-hand side, actually 5, 4, 1, 3, 2 makes a lot more sense. And there's also hundreds of individual requirements within that document. So is the ADB fit for purpose is my question. Now that photograph at bottom right shows all the different bits of legislation guidance that I have in my office here, that I have to plow through to design any building. And the green box top left is the means of warning and escape functional requirement, which is incredibly vague and aspirational. Now, in between that, we've got an approved document, which is not mandatory. How on earth can you work your way through all this conflicting and confusing, often conflicting, often confusing, arguably very clear to lawyers, but frankly, not to most of us. So when we look at Grenfell itself, we have a tower block in a green landscape, but actually fire brigade access was inadequate, albeit they were fighting the fire from a firefighting shaft, but fire tenders, and it proved aerial appliances still had to get near the building and couldn't because of landscaping, parked cars, and other features. So we failed part B5. So when we look at the building itself, we have originally on the right hand side there was a previous design proposal showing alternative means of escape from each flat, and the blue bottom on the left hand drawing shows the sort of flat sizes, 4 of them originally, and you would escape from on the right hand side 2 escape doors into exactly the same yellow lobby area. Now, actually, that's not an alternative means of escape in my mind, and certainly at the time, it seemed to be a way of achieving a waiver for 1 staircase. Get rid of that other staircase. We don't need it. It's got an alternative means of escape. Okay, so we now look at what was finally built. We actually have 6 flats per floor, all with 1 escape door. So that alternative means of escape was lost. On the left-hand side, we've got these 1-bedroom and 2-bedroom flats, just 1 door out, 1 staircase. 24 stories, is that an alternative means of escape? So the regulations were being relaxed at the time. Also, in this 1 staircase, we've got, going from top to bottom, we've got a lock gate at the roof, which prevented people getting out. Whether that would have helped them or not is another matter. But then there's gas pipes in that staircase, which apparently when they were turned off, the flames reduced. The old fire lift was not working on the day. There's no wet riser, which was required at 60 meters. There was obviously the 1 staircase waiver. There was no sprinklers at 30 meters, and above 100 foot that was required in the time that Grenfell was originally built. So these things were relaxed massively over the years. And then there's community use down at these lower levels, which would have required alternative means of escape. So historically, things have gone wrong. Looking at the external walls and this famous diagram, I'm not going to go into the detail, but the red box on the left-hand side shows an 18-meter high, above 18-meter cladding issue, and it's very clearly stated Class O surface spread of flame was acceptable, but the building regs, according to Sir Martin Moore-Bick, supposedly failed. but the approved document said it was okay. So there's now, we think, although the statistics vary, some 3,500 buildings with this Class O surface spreader frame cladding, and are all the designers and contractors guilty as a consequence? That's a question for everybody. So service penetration throughout the building, these all failed. So internal fire spread, compartmentation was completely ruined by these. We know the fire doors failed. We know the compartment walls might have been okay, but we're not totally sure because they had holes punctured through them for services, gas pipes particularly. And invariably, there's raised floors, there's other voids in the building, which cause all sorts of problems. So the actual building on site, it's necessary to have supervision from clerks of works. We know the stay put policy works 95 to 99% of the time, but actually Grenfell and Lacanel and various others have actually gone beyond that. So we know that we have to deal with unusual circumstances. Plan B, there needs to be an evacuation strategy, not just stay put. So we know that the fire brigade, when they get into the building, they have to fight the fire from bridgehead, 2 floors below the fire floor. They then have to bring equipment and kit up and hoses and attach to dry risers. And these hoses actually sit on the staircase. And thinking of people coming down the building whilst these guys are coming up, it suggests that single staircase buildings are not designed to facilitate simultaneous evacuation. So a drill I visited at a project in a fire brigade drill in Brighton showed firemen in a refuge area, albeit it was external on a balcony because the lobbies were too small. The hoses were rolled out on the staircase, and the hoses looked like that once they were charged up. Now, who can escape through that zone except for the very able and very ambulant? Not many other people, including myself. It was very difficult to work our way around those. So we go back to 1962, and we have fire legislation. The RIBA have gone back into history to see how did this work in the past, and we had a place of relative safety, which the building regulations or the approved documents certainly still encourage. Protected lobbies, not just a corridor. No flat doors in that corridor. And this protects the firefighters and vulnerable people. So moving on into 1974, about the time that Grenfell was actually originally built, there's actually a requirement for buildings over 100 foot to have sprinklers, plus also a fire stair, which is protected, is ventilated, has an external window, or at least ventilation at the top, and a firefighting lobby, which is also a vulnerable person's lobby, has a fire lift, it has a dry riser in the lobby, so the doors aren't propped open. These have all been relaxed in the Grenfell situation. So we come up to 2010, and we end up with these diagrams relating to small single stair buildings or buildings with a common staircase. Now, every flat should have access to an alternative escape route. Well, how did that work? It wasn't available. Single staircase buildings, the top floor of the building is no more than 11 meters above ground with a single stair. And that was current. That is still in the current approved document. Short dead end travel distances, 4.5 to 7.5 meters. 7.5 is smoke control. At Grenfell, we know is around about 9 to 10 meters. Not too far exceeding, but greater than the current regulations suggest. So we end up with a core like this at Grenfell, full of smoke because the doors are left open, no door closes, or people have left them open because they want to escape back if they can't get into a staircase. They need an option to turn back. And this actually shows it did not work. It was not a compliant scheme. So at the RIBA, we've come up with trying to A, remediate Grenfell, or B, come up with a solution to deal with similar types of cores, with the green zone being this refuge area, firefighting lifts and disabled access lifts, a protected stair, and dry risers in the lobby, not in the staircase, propping doors open, affecting everybody else escaping. So we know our industry cannot deliver fully compliant buildings in terms of structure, in terms of fire protection, and the Edinburgh Schools demonstrates this. The diagram on the right shows how many defects are often found in major public buildings and other buildings under a design build contract. So these contracts are seen as a major part of the problem. So things failed on site with these. We need greater site supervision. We need better drawings that can actually help through the design stage to produce design information, which can then be passed on to the contractor and built, and then ultimately passed on to the client to actually manage and understand his building, and for future people to now take this on and realize how they can modify the building based on the existing fire strategy. We have specification information, which we're now trying to tag with red flags, if you like. They're mandatory. We don't want these design value engineered out in the guise of fire engineering. Actually, it's cost cutting by another term. So at the RIBA, we've put together some looking very complicated, but actually understanding this issue of the current regulatory situation. How do the current regulations apply to existing buildings, buildings currently under design, and buildings in the future? And putting together a set of prescriptive, but still reasonably flexible in certain areas, legislation or guidance, which can help everybody to come up with better solutions. We then start looking at how this relates to individual buildings, analysing it in relation to Lakanal and Grenfell, finding how it currently works and how we would rather it worked in the future. So we spent a lot of time historically researching the fire engineering, put it into modern day practice, and coming up with solutions for all types of buildings. So Grenfell failed for many reasons: fire engineering, design and construction complacency, incomprehensible legislation and the framework of the regulations and the deregulation over the years, inappropriate materials and value engineering, management shortcomings, contractual procurement misdirection. Is design build the best thing for producing a fire safe building? Possibly, but it needs considerable modification. Maintenance inadequacies. We know the building was not maintained well, it had been refurbished, and we know the smoke extraction system failed. The fire lift failed. Can we rely on mechanical means to increase travel distances or to allow higher buildings? Question mark. Firefighter training inadequacies for total evacuation. The firemen did a heroic job, but the firefighting training was inadequate to help the total evacuation. And then competence issues across the whole spectrum. How can you actually, as a designer, work and supposedly be competent when the regulations are so ambiguous, they are so flexible and often, frankly, incomprehensible? So I would suggest that the whole industry, as Dame Judith Hackett suggested, are at fault. There's systemic failure here, and this is complex, creeping and collective myopia from everybody. Thank you.
Thank you, Paul, and indeed all of our panellists who now join our chair for this panel discussion session. Jane Duncan, past President RIBA and Director of Jane Duncan Architects.
Well, good morning. Thank you very much. I'm quite sure that everybody that's been listening in today, and I understand there's a lot of people listening in, have heard 4 really interesting talks here. And for me, there are a lot of questions that come out of these talks. We have got one person that sent in a question. I, in fact, have a whole string. So as you'd expect, I might start with a bit of a controversial one. If we could ask our panelists, I'll suggest we start with just going around in the order in which you started your discussions today. I want to ask you about high-rise timber frame buildings. Now, I'm speaking at the moment from my own home, which is timber frame. I'm a bit of an eco-warrior myself, but I am really worried about high-rise timber frame buildings. What are the outcomes that Tom has been talking about? Can we achieve not only safety for people, but also safety for the buildings? And do we have a building industry that can build well enough that it all works the way we expect? Right, so I'm going to ask Tom if you'd like to come in on that one for us.
I think there is a lot of debate around timber, whether it's mass timber to what I'll call stick frame. Are we talking low rise? Are we talking high rise? For me, talking personally, there's still a lot of research going on in this field. And it's not just about whether when we build it, the structure is going to stand up. The issue is about the life of the building. And there are still some areas that we need to sort of understand more closely. And they're around maintainability, repairability, and what actually happens to those structures over time. So for me, there's still some questions and some work that's needed to be done to sort of answer those questions fully. I know a lot of people will tell me there's a lot of good practice out there, but a lot of that's relative to structures and how long a structure will stand up. I know we use the term charring, I still call that burning, but it's really about, do we fully understand how these buildings will, be maintained, how they will operate over time, and will those vulnerabilities that are inherent in some of those buildings, I'm talking about voids and void spaces, will they still remain vulnerable over time? So I think it's a question, for me, the jury's still out. Research is needed.
Well, I have to say I tend to agree with you, but I'm really interested to hear others' views. So I wonder whether we could ask Iain what he thinks on this one.
Thank you. Yeah, I agree with Tom. It's early in the day. What we're seeing is, unfortunately, what we're doing with the buildings in general is we're conducting a sort of real-world, real-time experiment. A lot of stuff, we won't know what's going to happen to it until it's been stood for 10, 20 years. You can do some tests, and I don't think we do enough testing, but some tests are done before the product or the technique is allowed. But then we don't actually know how is it done in practice in the field, because you can see in various cases that the way it's done perfectly for a fire test is not the way it's done in the real world. I don't have a problem with the product. The char rate, as Tom referred to, it burns at a certain rate. In some ways, if you're crawling into a building on fire, a good thick oak beam is just as good as an unprotected steel beam, in fact, better. But I do have a problem with the fact that people tend to be putting them up on the basis that they think they know how they're going to react over time and under other conditions, such as fire conditions. Actually, they have an idea. They don't have any evidence.
It's an interesting area, isn't it? I've got a few very interesting questions that have come from Q&A. Thank you very much for those that are joining in. One of them is, I think, very relevant, which is about regulations applying to school buildings, etc. And there's no question in my mind that we are dividing buildings up and making perhaps a two-tier system out of this. But I have got a question I'm going to ask Mark, and I'm going to ask Paul to join in about whether or not we should in fact be building buildings that are fireproof for a flexible future. We're looking at permitted development at the moment, which is allowing offices to go into residential. Who knows what else is going to happen in the future? Should we just be committing specific regulations to specific building types? How do we make that work in the future? I know Tom had a view on this. Mark, how can you fireproof buildings to allow them to be flexible?
It's really what I said about really designing building on a case-by-case basis. Obviously, originally, you need to design it for the use that it's intended for. But it doesn't mean to say that you can't refurbish and retrofit buildings and still have a fire-safe building. You need to obviously be able to modify that building and apply the right mitigation measures to make that building viable for its use. It has to be fit for purpose and fit for the use of the building. So I think trying to future-proof something for all eventualities at the start is probably not the right way to go. But obviously, a good understanding of fire mitigation measures, how they interact in a particular building for a particular use, is the most important aspect of any fire engineering design. You've got to remember that Grenfell itself, the result of that outcome was it was a refurbished, overclad building where the design and detailing was a lot more difficult to actually achieve and achieve in practice than it would be for, let's say, a newly built, modernly designed building. It's got to come from a greater understanding of how buildings behave. And then perhaps the other issue, coming back to the timber frame point, is that scaling up from small scale tests to try and understand how a building, which is much larger in scale, actually behaves in reality is perhaps one of the key areas which is not being addressed at the moment. And this is a sort of a question for the supply chain in terms of the testing that they're actually using, standardized testing. They need to be looking at that and moving away from that to try and understand how their particular products are actually going to behave in use. So again, I think that's a big area of research which needs to be taken. But that's just my particular initial thoughts on that question, Jane.
Thank you very much. I don't know whether you can still hear me, but I've got problems with my internet connection. Can you hear me?
Yes,
we can.
Okay, right. Well, I'm going to continue. I may have to log off and try logging on again because I can't see anything at the moment. But I wonder whether, Paul, you'd like to come in on that discussion.
Certainly, Jane. Thanks for the opportunity. And the first question was timber. Second question was the dividing buildings up. But certainly, I think the question that I'd like to ask is, what do people do in the building? And do they sleep in the building, or are they awake and aware? And I've just been referring back to the old Code of Practice Media Escape Red Book, which some of the other delegates on this panel might well be aware of. But places where people sleep are different to places where people resort and places where people work. And I almost think rather than breaking up the regulations into dwellings and other buildings, and having perhaps what's referred to as two tiers or other sort of complex and simple buildings, but actually it's, fundamentally, what do we do in the buildings, and thinking about the people. And the fact is that we have to design for the I would say, doesn't sound good, but lowest common denominator, i.e. the most vulnerable. And that would mean then all our buildings would have to be designed for the most vulnerable. And that perhaps might have an unnecessary financial problem with offices or factories or buildings of that purpose group. So as long as people aren't sleeping in those buildings, I think we should be treating them separately. It's interesting, we were discussing earlier, is this conference about all building types, or are we being focused primarily, because of Grenfell, on the sleeping risk buildings, places where people live and get older or are born and die eventually, hopefully without the effects of fire? So I think we're perhaps asking the wrong question.
Or perhaps you'd like to ask another one then.
So can we start getting some legislation which is actually reflecting that and is actually comprehensible, such that people can actually then be competent to deliver it? Because with ambiguous legislation, how can we possibly be proven to be incompetent or competent?
Jane, if I may, I think that I see that sort of that adaptation over time. There are two key barriers for adaptation of buildings, or how do we future-proof buildings? And one of them is information. We seem to be very poor at collecting information and keeping information. By going to Mark's point, we design a bespoke suit and then we try and fit it onto somebody else, but forget that some of the features that we put into that suit need to be amended. And then we do something even worse than that, and it's called a non-worsening clause. We then put some more constraints in law that say we don't have to do some of those things if we're not making it any worse. So for me, I think there are two barriers that we need to overcome, and information probably is the one that is in most of our hands, collecting the right information about how a building was designed and what are the key features, so that anybody else coming along can walk in those footprints and say, actually, that's not suitable for this new use. So going to Paul's point, if we've seen a demographic shift and more vulnerable people are using that building in the future, and we designed it for all-out evacuation, and that's now not possible, we've got to shift our thinking. We've got to adapt. So I think it's about information. And sadly, I think the non-worsening clause that we have in some of our building regulations today needs to be changed.
Yeah, there's a lot of work to be done to building regulations, I think. Coming back, actually, interestingly enough, to the timber buildings, there's a very interesting question that's come through to say, why should we not be looking at best practice from other countries and adapting that here to our regulations, or adapting our regulations to work with whatever the other countries have? I think, Tom, do you know whether there is legislation around the world with your WSP knowledge? Do you actually think that going a bit further than just looking at our own regulations might be helpful?
Is that a question for Mark? Or for...
I'm gonna ask you both, actually. I'd like both Mark and Tom.
Yeah, I mean, obviously, as a global company, we are well aware we've got 5 engineers all over the world, and there's different legislation, and it's derived in different ways. Most legislation derives from tragic events that occur during the history, and then the legislation tends to be quite reactive in response to that. So you do have different regulations in different countries. For example, in the US, you can't do anything in the actual residential apartment because that is somebody's right to do what they want in their apartment. So you can't have sprinklers in apartments, where in the UK, we have no qualms in putting sprinklers in apartments. So there are different aspects of the fire strategy which developed over time all around the world. So yes, there are differences, but there is, but you can learn from best practice because, because the common set of principles in terms of fire safety engineering should be applied wherever you are in the globe. And this is what I was trying to say about the danger of prescriptive guidance. In the US, it's very prescriptive. But do you want to go down the route of very, very prescriptive guidance when really you need to fit a fire strategy to the actual building that's in front of you, when the one you're actually designing?
I'm going to ask a question I'd like everybody to comment on, just on the basis of what you just said, Mark, which is about prescriptive guidance. And I think that what we've got here in the UK, and I dare say it's the same around the world, though I'm not knowledgeable about it, is that we have prescriptive regulation and then we have guidance. And I have a concern that some of the guidance overrules the prescriptive regulation. And I don't know whether that's an issue or a problem, or whether it's, as Dame Juliet Hackett said, a way that people can game the system. But perhaps you were talking, Mark, about things being better as a result, because you can use your knowledge to improve matters. But I am concerned to hear different people talking about regulation differently from the guidance. Paul, you put a lot of that into your particular way of route that you showed us around the building regulations. What do you think?
Well, thanks, Jane. Certainly, we need to get balance of prescription and the other. Sorry, but actually, performance-based is all very well, but we actually need to quote a highway code. We need a speed limit, and it's no good just saying you can travel at an adequate speed to prevent accidents. Everyone interprets adequate as something different, and adequate keeps reoccurring in the functional requirements. So what is adequate to one person is not adequate to somebody else, hence the gaming of the system. So we need an element of prescription, but not to be so mandatory that it doesn't allow some flexibility. How we do that, of course, is going to need the wisdom of Solomon and a group of people like ourselves to actually try and get our heads together around the industry and come up with what we think is appropriate. I don't think currently we've got a team of people necessarily out there who are perhaps in the best place to do that, because they perhaps wrote what we currently have. We almost need to go to somewhere different.
Can I come in?
Yes, please do.
I think, going back to my experience when I was, an enforcing officer with the Fire Precautions Act, people used to say, that was seen as quite prescriptive. And indeed, in some cases it was, in some areas it was. And people used to come up to me and say, well, this is slightly different, this situation. And my answer to them was, do you want flexible uniformity or uniform flexibility? Because they always wanted to make their case that this extra meter, or the fact the fire door couldn't be fitted into that area, could be got around. And in many cases, as Mark has explained, it can be. But the trouble is they just wanted to get around it because it was inconvenient. They didn't actually have an answer, they just had a problem. And the answer to the problem, going back to Tom's talk, was to drop under the minimum. But as an enforcer, I kept getting this, that the regulations, when you have prescriptive regulations, people will rail against them. And in some cases, and I have to say, sometimes you find it's not really appropriate to try and put it in here. My problem is when people who don't know what they're doing try to find a way around a problem. If you've got people like Mark and his teams working on it, that's fine. But when you've got somebody who just said it's a problem we don't need the fire door or whatever, that's where you would end up. And you can't police every building. Going back to your timber frame, it's different now. I think it's a 7-story timber frame extension being put on a 10-story steel and concrete structure. I'm trying to remember where it was. It's not this country. So we can learn from abroad, but that's different. We haven't seen that before. Who knows how that's going to behave?
Yeah, I look at this and I go back to Ian's triangle. One of the issues, prescription in my opinion, is a good thing in terms of clarity. We want flexibility. The challenge with moving to a performance-based system totally is a bit of an arms race. Enforcement needs to keep pace. So if you have performance-based designs coming through and they're being proposed as alternatives to what's in guidance, then the enforcers need to actually understand that to ensure that it's right. And when we get them out of balance, then I think we're in a troubling situation. Working internationally, there's a lot of discussion about this going on around the world, particularly for countries that have moved into performance-based codes, because they're seeing this disparity between the practitioners and what's happening in the enforcement community. And the middle ground seems to be, what's the method for verifying that the performance-based does what it says on the tin? And the performance-based community is railing against that slightly, because that looks like prescription for performance-based solutions, i.e. your performance-based solution must meet these requirements. But somewhere in the middle is probably that answer. And we have a particular challenge in our country in the fact that a lot of our guidance is technology neutral. So when somebody comes along with a new piece of technology, they're trying to fit it into a guidance regime that's particularly technology neutral. It doesn't talk about specific things like CLT and other systems like that.
Yeah, I think as an industry though, in the UK, we don't make enough of peer review, and that peer review mentality and process needs to be gotten into the industry to enable these performance-based approaches to, so if the enforcer doesn't have the knowledge, then you should be going to somebody who does, who's independently reviewing those solutions.
Thank you. I think I might take a couple of questions from the delegates, and I've got a couple of technical ones. One from Peter Hokum. Thank you very much. An interesting question. I don't know the answer to this. Does anybody? Is a building with a virtually 100% green wall externally able to be compliant? Who'd like to take that one?
I guess
you've done it.
I guess the question, you've really got to go back, and I'm going to answer it with Paul's point, which is you've got to look at the functional requirements and satisfy yourself that you've actually met them. And therefore, asking that question, is it compliant? You've got to actually demonstrate why it is compliant, particularly for what's in the building. So what's the risk that's generated by having that particular green wall solution? And that, so it's not a black and white answer, I'm afraid, but there is that element that you have to demonstrate why something is compliant and how you're satisfying that sort of functional requirement.
So Jane,
I would say that there is definitely international best practice. I came back a year or so ago from Singapore, where this is green wall city, and the regulation is unbelievably tight. So there must be a way to be able to make these things compliant, depending, as you say, on the circumstances. Yes, Paul, sorry to interrupt.
Jane, what I was going to say was just trying to draw an analogy here, because, I know everyone's of the view that the cladding, combustible cladding on the outside of a building is not dissimilar perhaps to this green wall. Actually, given a building that's appropriately fire protected in all other respects, and that the fire is contained by the sprinklers, we've got cavity barriers around the windows preventing fire spread outside, and that you're actually got good compartmentation and an adequate means of escape, then as we know at La Crosse in Australia and the Torch in Dubai, everyone got out. There was some fire extending on the outside of the building, but they contained it. So actually, I'm not promoting using combustible cladding in the future, but we've got thousands of buildings which currently have it on. We've got people who are completely, from an insurance perspective, blighted. They cannot move. Can we not remediate those buildings to satisfy insurers and to satisfy the public such that they are appropriately safe? Albeit there might be some building damage. So we need to unlock that part of the industry. And that's an interesting analogy between green walls and flammable cladding.
Certainly. Anybody else want to come in on this one? Otherwise, I'm going to move on to another one. I've got a question here, another little technical one for you. Paul Caford's asked, in retrofit, and a lot of us are doing this at the moment, looking at internal wall insulation, he's saying it's difficult to manage the moisture properties with fireproof material. Have any of you got any solutions for him? Get your answers here, hopefully.
Water ingress, is that what we're referring to as moisture problems or condensation?
Well, I wish I could ask Paul, but I'm expecting it's probably condensation, because those are the difficulties I faced.
Right. So, I mean, if I, as an architect, we have to balance all these issues, as people were saying, it's holistically, not just from a fire engineering perspective, but from a sustainability, a thermal point of view, a water ingress from rain, wind, etc. So we have to balance all those, not to mention the aesthetic criteria. So that is our day job as architects. You know, fire is just a small component of that, that overall picture.
Right. I'm going to move on a little bit to something which is part of the discussion today, but it's a bit of an elephant in the room, I think. And I'd like you all to have a think about who the heck is going to be the person that's going to be accountable? Whose neck is going to be on the line when you're building a building? We've seen what's happened at the inquiry, and there were no necks at all, as far as I can see. What is the right way in the future? And who'd like to come in on that one?
I'm happy to start, unless someone else wants to.
You go ahead then.
Okay, so I think all indications are, apart from the accountable person, the building safety manager that sits with the client, there's going to be a principal designer and a principal contractor, if all things go to plan as intended. And certainly as principal designer, that is generally sitting, and although there's different views on this in CDM, sitting with the architects or the primary designers in buildings. It's going to be the architects, and we're not going to stick our necks out unless we have a team of people, including fire engineers, including approved inspectors or building control who are competent at their job, including clerks of works and site supervisors, including contractors who have a track record of providing this appropriate level of detailing, and they don't change the design as they're going through the process. We actually got to return back to some perhaps traditional methods, the way we used to build back in the 70s when I started as an architect, and actually we need to think about how we completely change our industry to deliver that. Then I'm happy as an architect to sign it off. Without that, I'm not.
I understand that one. Anybody else want to come in on that?
Yeah, again, with some prosecutions I've been involved with, etc. The health and safety, and the regulator will be under the health and safety executive umbrella. They always look for the mens rea, the controlling mind. Yes. And I think it's going to be the legal framework, the legal definition of who's responsible, whether it's the accountable person or whatever. But there will be this, forget the golden thread, which is about the building and the risks in the building. There's going to be a legal thread. Somebody is going to end up holding the can. The Dutch fire service have a lovely tradition. They have a little, basically it's a baton. And you know who's in charge on the fire ground? They're holding the baton. And you know, if the decision's taken while it's in your grip, it's your neck. And I think we need something similar to that, you know, it's almost like a big finger saying it's you, so that when you are asked to sign it off as the principal architect or whatever, you know what you're signing and why.
I mean, my point of view is ultimately it's got to rest with clients and developers, because they are the ones that employ the professionals who are going to be designing and constructing the building. So it's got to start with there, and they've got to choose competent contractors and designers who have done it many times before, like and had safe buildings, like not just appoint people on the lowest price. That's the problem.
Yeah,
we've got to get away from that culture.
Yeah, we've had many discussions on how do you know who you're going to get at the moment. I've got a really interesting general question here from Bob Eden, who's, I think, made a really important point. He says much of the problem is not just about information, whether it's consistent or contradictory, but very much about clarity of communication allied to a point of authority. It follows on from the last question. And he says that he's held that people should be made to watch Towering Inferno, which he describes as a story of incompetence, an imperfect world, and a stunningly heroic architect. Well, I'm all up for that one. But I think he's got a point about communication and authority. And maybe we could bring Iain in on that, because you've seen what happens when that goes wrong.
Yeah, don't get me started on Towering Inferno.
No.
Wandering around a building with your tunic undone, jumping in and out of, anyway. The firefighting is not to be held up as a model there. But on the principle that, what's at the end of the film? It says, you keep building and we'll keep putting them out. Why? Don't build them to burn. In the end, there's a big tank of water, I think, that collapses, doesn't it, and miraculously puts the fire out. I think we shouldn't be relying on luck. I'm all for innovation, but I think we should be, you don't put a new car on the road unless you've crash tested it a few times. We need to be doing that with different building techniques. If you look at a lot of hotels now going up, they're modular. Now again, who's to check that every bit of that module has been put together properly? It comes back to competence, it comes back to my anti-fire triangle. But competence, I think you need third-party certification. You need somebody checking the, this is trust and verify, if you like. Somebody needs to be checking the checkers. You can't have an infinite layer. It's not like, you don't have a police car following every car on the road to make sure it doesn't speed, but there's enough of them out there to catch you, to make it likely that you might be caught if you keep speeding.
Okay, and who is going to catch people in the future?
Sorry?
Who do you think is going to catch the people in the future?
Well, the regulator, it's going to be interesting because the regulator needs to work with local authority building control or
Yes.
authorities and the local fire and rescue service. It's very clear that that has to work. I don't have the foggiest idea of how it's going to work. To me, a danger there is that there'll be a different team of 3 people from those different bodies, if you like, at each gateway and in between. You do need this common thread coming through. I think Mark mentioned it. You want the same people at the end of the project as at the beginning. If you clients, and I think the enforcers have got to be consistent as well.
I think that communication piece is vital. If there's a shift that we have to make, it's around information. And I go back to my point about outcomes. It's being very clear what we're trying to achieve and that discussion happening. So going back to something Paul said, people are trying to do things. It's being clearly communicated who's accountable, but who's also responsible for actually getting the task done. And then that verification is that process of saying, well, let's make sure, because if there is a critical path there, we're used to that thinking that certain things have to get done in a series. I don't think it's any different in fire safety. When we've come up with a design, there are certain critical points that have to be met. Now, whether that's the material we've chosen for the outside of the building, or the sprinkler system we've designed in the building, or a particular wall has to be of a certain resistance, there are certain points where it's very clear that that outcome has to be checked. And that's, I think, where the communication needs to be, is that everybody understands those points and looks at them. And when we talk about verification, it may be somebody coming in as the police and checking that it's done. But also, I think that needs to rest with the people in that process to make sure they all understand that's important, it needs to be done right, and not accept the situation where somebody might have done it. It needs to be verified. And that's the surety that you give to somebody else when we're talking about whether it's a safety case for a high-rise building or any other building where we're trying to sort of demonstrate we've done the right things to satisfy ourselves, it's okay. And here's why we know it's okay. And that's where the golden thread, I think, will be an important part of this for every building. I know we're talking about it for high-rise buildings, but for every building.
I agree. I think it has to be every building, doesn't it? Yeah. Now, we're nearly at the end of the morning, and I have to say we've still got a few questions, which I think some of them are quite technical, but there's one, Mike Smith, I love your question. We need another complete day to talk about the panel's views on current procurement routes. And I think if you say don't get them started on it, we're going to end up with, I think we need another complete day on this. And I certainly hope that that's what we can manage. But I do think that we've had a really interesting conversation. I think we've had a morning of very, very good work by the panelists. Thank you very much. This is a very large issue. And I'm going to leave you with one question just to think about. I don't think there's any possibility that we're going to be able to deal with this in one short session. And we need very many more. But so long as we're talking, and you're quite right, Tom, communication is the key. We need to be talking. What I'm going to ask you to take away is a question, which is how on earth can this industry work better in the future? Communication is one issue, but I mean, it is really true collaboration pie in the sky if, as we've been shown, the obstacle is really the culture of the industry as it stands at the moment. And Jane Judith Hackett saying everybody's gaming the system and there's a race to the bottom. My view is also that it can take years to build up competence in all the members of the industry to make sure that any building that you commission actually says what it is on the tin, if you like, the drawings and specifications. we've got a problem in this country. I think I was told recently from somebody that's not in this country that the UK construction industry has some real problems to deal with. And whereas we were thought as the pinnacle of good quality, I think we've got some work to do. So I think let's just take that away and have a think about it. Maybe we need another one of these to discuss it. I would like to thank Architecture Today very much for putting this together and giving us 4 very, very interesting panelists. And thank you all for joining in and listening and for your questions. I might ask for the very technical ones to be dealt with, if you don't mind, members of the panel, to come back to them. Some very general ones. For me, yes, there's an awful lot that we need to do. And I wish we could talk about procurement, but that's another, well, I'd like to say half an hour. It's probably about 3 or 4 hours worth before we even ask the question. Thank you very much. We've got roots. We know we can use them. Let's talk about building modeling. Let's talk about modular construction and how that can help. We're looking after all at one main thing, and that is quality. How do we build a really, really sensible quality building product into the future? Whether it's, yes, it's fire safe and it's fit for purpose and it's affordable, and it means that we regain the trust of the people in this country. Thank you very much for joining in today. And I'd just like to say thank you and have a very good day. Keep thinking about this. Thank you.